Hey guys, this week we are going to start by looking at some math properties. Some of these you have seen before and some of them may be new to you, but these are going to lead us into our next unit where we are going to look at some algebra concepts. So let's get started. These are going to be your notes. I'm going to show you what they're going to look like on the computer that you have, and then that you are going to have to copy the slide and paste it into your into your digital notebook, or you're going to have to handwrite this in your notebook. So these are notes that should be going into the expression section. I believe it should be the third section. You should have number systems and then ratios, and then finally you should have your expressions. Okay, let's get started. Okay, so now we're going to take a closer look at the properties of operations. First, we're going to start with the associative properties. So let's zoom in a little closer there. So when you see the word associative, you might think of the word associate and think about maybe your friends, like who you associate, the group of friends that you hang out with. So what this associative property is saying is that by changing the groups, groups of adding or multiplying numbers does not affect the solution. And a solution is an answer to a problem. So if anytime you're asked what is the solution, they're asking you to solve that problem. And remember, you can pause this at any time to write down these notes. Okay, so example. So we're going to do an adding, and we're also going to do a multiplying example. So an example of this would be if I had 5 plus 2 in parentheses plus 4. Okay, we could say that is equal to saying if I did 5 plus parentheses 2 plus 4. So it's regrouping, okay? But notice they are all adding in this, and that only works when it's the same operation. Okay, same thing is true for multiplication. I can say that 5 times 2 in a group times 4 would be the same thing if I regrouped it and said, what if I did 2 times 4 first? So we can check these to make sure this is true. If we look at the adding, 5 plus 2 here is 7, plus that 4 is 11. On this side, we would do the adding the 2 plus 4 first, which is 6, plus 5 is 11. So they both give us 11, and 11 equals 11, so it is true that the associative property proves equivalence for adding. So let's try it for multiplying. So 5 times 2 we know is 10, times the 4 is 40. But on this side, we need to do the 2 times 4 first, which is 8. 8 times 5 is 40. So we can see that both sides equal 40, and that is why the associative property works for proving equivalency. Okay, now let's move on to one of my favorite operations. I use it a lot when I am working out math problems, is the commutative property. So when I think of the commutative property, I think of commuting, getting from one place to another, commute to move, okay? So what this is saying, changing the order in addition and multiplying problems does not affect the solution. Oops. Okay, so when we're talking about the order, so this is an example that you learned all the way back in elementary school, is if I have 5 plus 2, it's the same thing as 2 plus 5. That the order that I solve them does not matter. And this is true even for if I had 3 numbers. So another example, because it's also multiplying, you could say 6 times 3 is the same as 3 times 6, because they would both equal 18. So that's what the commutative order means, is that I can move things around and add them in different orders as long as it's the same property. Okay, now let's move on down to the distributive property. Okay, for the distributive property, this is probably one of my favorite properties as well. I'd say it's my favorite out of all of them, just because I think it's fun. Okay, the product of a number, so we have to remember what the word product means. Product means the answer to a multiplication problem. The product of a number by a group of numbers added together, so group is really important, added together, is the same as doing each multiplication separately. Okay, let's look at what this means. And you've seen it before because I've seen it in a 4th grade classroom. You just might not have remembered the word distributive. I like to think with distributive property is like the mailman distributing mail. So they're saying that if I had a problem similar to this, that it's the same thing as doing 5 times 3 plus 5 times 2. Okay, let's test that theory out. Well, 3 plus 2 we know is 5. And we learned during order of operations that a number outside parentheses means to multiply. So 5 times 5 is 25. So then over here, 5 times 3 is 15. 5 times 2 is 10. 15 plus 10 is 25. So yes, it's true that the distributive property does work and make equivalent expressions. What this may look like with variables would, if I had the 5 and let's say I had x plus y, that would be the same thing as doing 5 times x plus 5 times y. So you might write that down as another example for that problem. But so what I mean by it distributes like the mailman is the 5 is being distributed to both numbers. Like the 5 delivered mail to the 3, the 5 delivered mail to the 2. So that's what you see over here is the 5 distributing itself between the two numbers. Okay, and our last part of our notes is the identity property. You learn these definitely in elementary school, and it's just reviewing them. You might not have known that's what these are called. So we have the additive identity property. So when you think of identity, you think of yourself, like what you identify as. So think of that would be the same as numbers. The sum of any number and zero, I accidentally hit a button, Sum of any number and 0 is the original number. So what that means, if I do 5 plus 0, it's 5. It doesn't change the identity. Same thing with x plus 0, it's still x because nothing has been added to it. So that's what identity property means. So now let's think, what does that mean for multiplication? So if I'm looking at the multiplicative identity theory, think about what number would not change the number. So the product of any number and 1 stays itself. So 5 times 1 is 5. So x times 1 is still x. So those are the 4 properties we are going to be talking about, and then we're going to do a few practice problems to make sure we understand. Okay, now we're going to take a look at the practice page, and we are going to identify what property each problem is representing. So let's take a closer look at the first one. So we have 10 times 7 is equal to 7 times 10. So we can see that the numbers just switch spots. So when they switching spots, that's commutative. They're commuting their spots. So we are going to move the commutative over here. Okay, now we're looking at the 2 times 1 equals 2. So if we're looking at that one, we should see that, it was 2 times 1, which left us with the number 2, so it kept its identity. So that's your identity theory. Next, we're looking at the 5 plus parentheses 6 plus 3 is equal to 5 plus 6 in parentheses plus 3. So we should see that they're grouping things together. They're associating numbers to each other. So that means it's the associative property. Okay, next we're looking at 4 parentheses 3 plus 5 equals 4 times 3 plus 4 times 5. Hopefully you noticed in this one that we see some distributing happening. The 4 is being distributed to both numbers. So we're gonna, put it back on. Not both, hold on, I'll just grab one. We're gonna distribute that. The one below it we see is 18 plus 20 equals 20 plus 18. So hopefully you're thinking, oh, it flip-flopped. So that's the commutative property. They're commuting. And then the one below it says 15 plus 0 is 15. So notice it started 15, it ended 15, so it didn't change its identity. It's the same number it began with. Okay, let's take a look at these bottom three. So we have 4 times 3 in parentheses times 2 equals 3 times 4 times 2 in parentheses. Notice there's that grouping. They're grouping things together, so they're associating with one another. So hopefully you're like, yes, associative. Okay, then we have y times x plus z in parentheses equals y times x and y times z. Oh, did I hear you say it? I think I did. It is the distributive. You see that y is being distributed to each one. And then our last one, we have x plus y equals y plus x. So we can see they are switching spots on us again, which we know is the commutative property because they're going from one spot to another, which is what commuting is. Okay, so I know we did a lot today with our notes. So tomorrow we are going to practice this. So I would have these notes out so you can make it super easy as you complete Tuesday's assignment. This is Monday's assignment. If you have any questions or not sure about why something is called what it's called, or how you can identify the associative different than the commutative or the distributive, let me know. I will be on at 1 o'clock to help. Have a great day, guys. Bye.